Okay, here is the next algorithm that we can use for drawing a Bezier curve, right? And this one is seems to be easier to implement in a typical programming languages like C program or Java programming. If you can see that before we have already implemented the Bezier curve by using Mathematica, because Mathematica program is originally is used for symbolic computation, and then it can be used for polynomial easily. But if you want to implement the Burnside polynomial and as well as the factorial function, it would be very difficult to use it in Java programming or even for C programming. So in order to make it easier to implement, because we have been familiar with these kinds of programming languages like Java and C-based language, so the Casteljau algorithm will be used instead. Okay. I just told you that the Casteljau algorithm is a French mathematician, right? And he also invented the recursive algorithm. A recursive algorithm in order to recursive algorithm for Bezier curve drawing. Right? If you could see that if you want to draw a Bezier curve, right, denoted by dt, right, you have to write it in terms of the convex combination of Burnside polynomial and control point, right? We use B, bound B, in order to represent the name of Bezier curve. Okay, but instead of using B here for the Bezier curve, we use B N 0 T, or sometimes I will use it interchangeably B N 0 for short. The Casteljau algorithm, the equation is very simple. You just only use 1 and 2 equations. The first one is the basis. And this one is the recursive form. Okay, so if n is equal to 0, this will equal to the control point. Okay, let me say like this. If we have B0, B1, B2, BT, they are control point for the cubic Bezier curve. And in order to equate this equation, I will use B00, B01, B02, and B03 will be used interchangeably. So I would say that it is control point B level 0, B1 level 0, B2 level 0, and B3 level 0 for short. Okay, and then let's see the recursive form. Right? Recursive form can be written like this: BR, any R. Okay, it can be written in terms of 1 minus T plus T. You could remember, right? 1 minus T plus T is equal to 1, right? And this is the linear interpolation. Sometimes we call, if we like X and Y here, this can be called interpolation, linear interpolation, NEAR, linear interpolation. Okay. and here will be, see this is R and I, right? Here will be I and I plus 1, and R will be reduced by 1. Okay. So here we are. Where R from 1 to n and I from 0 to n minus R. This is the Casteljau algorithm. Very easy. Okay, in order to interpret this one, so I will use cubic Bezier curve in order to make it simpler for you to understand about the linear interpolation. Okay, starting from this, okay, suppose we have 4 points for cubic Bezier curve of degree 3, order 4, right? We have 4 points, B0, B1, B2, and B3. Actually, I can write it like B0, 0, B0, sorry, B01, B02, and B03. What does it mean by linear interpolation? Linear interpolation is like this. When you, okay, if you are considering T is equal to 1/4, okay, so B10 will be, okay, this is half, this is 1/4. So as I just told you, B01, like B0 level 1, B0 level 1, right, will be here. B1 level 1, B2 level 1, and then we connect them by drawing this line. So you have from 4 points, we will reduce to 3 points. And then change to green one. So the next step is, if we have this red line, so we, okay, this is half, this is 1/4. So here we get B0 level 2 and B1 level 2. And then we will connect this 2 points by this green line. And then the last one, we at T is equal to 1/4. So we have B30. B30, because it is n is equal to 3. So this point is a point on Bezier curve according to T is equal to 1/4, 1/4. This is the way that the Casteljau algorithm does. Okay, in order to make it clearer, right? So I've just told you that we can start from B0, B1, B2, and B3, right? Sometimes I call this one is interpolation scheme. This one is interpolation scheme. And then, as I told you, B0 equal to B0 level 0, B1 level 0, B2 level 0, and B3 level 0, right? And then we interpolate by 1 minus T. B10 is equal to 1 minus T, B00 plus T, B01. This V shape is 1 minus T and T. Okay, let me show you clearly. B0 1 is equal to 1 minus t. B0 1 minus 1, that is 0, and then plus t b1 b0. Can see? Similarly to b11, b11 will be 1 minus t b1 0 plus t b1 b2 0 b2 0, and b 1 2 is equal to 1 minus t b 0 2 plus t b 0 3. So we can do the same thing, and then until we can get only one value. This value b30, right, according to t, will be the point on the Bezier curve. In order to draw a Bezier curve, you need to calculate every point along the curve. Suppose you want to make it smooth, maybe you have to use 100 points. If you want to make it more very smooth, you maybe have to use 500 points. Okay, that's clear. Okay, here we are. Here is the formula. Okay, if I ask you in the examination, suppose I want to calculate a point on the cubic Bezier curve when t is equal to half, right? According to this one, this is the Casteljau algorithm. You can just simply substitute t by 1/2, right? We want to find a point at t is equal to 1/2, right? That is b30 1/2, right? T is n, right? N is equal to 3. And then you can simply substitute t by 0.5, and then you use the Casteljau algorithm recursively. 1/2 b20 0.5 and 1/2 b21 0.5. You can substitute like this, and then you can come up with this one. If you know, or it is given b0, b1, b2, and b3, they are 4 control points for cubic Bezier curve, so you can find the result. Okay, this is the way that I just to show you about how to complete with the calculation of the point on the cubic Bezier curve according to t is equal to half 1/2. Okay, so it's clear. And then the next one is, if you know the Casteljau algorithm, so the next thing that you may have to know, that is the efficiency of this algorithm. In order to find the efficiency of this algorithm, you have to find the complexity of the Casteljau algorithm. So in order to do that, we can use the technique of counting the number of addition and multiplications. They are all the arithmetic operators. In this case, right, in order to compute the Casteljau algorithm in the recursive form part, right, you have one addition and two multiplication. One addition and two multiplication for each recursion. So in this complexity, you can calculate, that is the inner loop, right? You will have I from 0 to n minus r. And outer loop, you have r from 1 to n. And then you have one addition plus two multiplication. Okay, and then we have to calculate for this one, right? we have this, we can expand it to this and to this. I'm not going into detail about this. You can calculate for, you can use the formula of the simplification of this series and summation, and then you can come up with the Casteljau algorithm require n multiplied by n plus 1 divided by 2 addition and n plus n multiplied by n plus 1 multiplication. So the complexity of the calculation of the Casteljau algorithm will be big O n square, big O n square. That is pretty good. Okay, when you compare this with the previous one, the polynomial, what do you think? Which one is better? This one is better, right? Okay, I have an active learning in order to calculate the point on the curve corresponding to the value t is equal to 0.75. Okay, who can find the result first? How can we find the result? T is equal to 0.75. Okay, this is the last one.คุณเริ่มต้นจากไม่มีอะไรนะ I have nothing. 10, 20, 0. Zero point 0.75. You are also quiet. 20, 0, and then 30, 20. So you can have this is my Bezier curve, right? If you want to find, you can just simply substitute t by 0.75, you can get the result. Okay, this is the okay, you can use Burnside polynomial and Bezier curve, right, in the term of the Burnside polynomial in order to find the value of a point on this curve, right, in active learning, right, when t is equal to 0.75. Okay, but if you want to use try program to use the Casteljau algorithm in order to find the value, what shall we do? First, you have to start from the base. Okay, I use the cast, the baseline. The Casteljau, we have t value. If you don't want to, we can ignore t. We have r and I. Okay, if r is equal to, it will be equal to have control point p nts. PTS, okay, point. Okay, it will be PTS at I. Ignore R. When R is equal to 0, okay, I will try to find the Casteljau, right? And I use control points here. Because I want to use I is equal to 0 and I is equal to 0. What's happened? This one I'm trying to use if I is equal to 0. Oh, sorry, I have to use. Okay, if I is equal to 0, then the class I is equal to the first point I. Okay, if I use I is 2, so I can get this one. Okay. If I is not equal to 0, you can use the cast. Okay, copy. In Mathematica, if you what's that? Okay, if you use two function of the same name, right? It could be divided as a recursive function or different rules, right? So in this case, you can think about it as you have two rules, or like in logic programming, or you have two lines. The first one is a basis step, and the second one is a recursive step, right? The recursive step, if you could remember, you can use 1 minus t, right? And then the cast, right? Use function the cast, okay. In the body, we cannot use underscore, right? As you guys have asked me, right? So you r and then r minus 1, I, and point. Okay, and then plus t. R minus 1, I plus 1. Okay, I can just simply like this, like the Casteljau. This is the Casteljau. The Casteljau algorithm. What's happened here? Okay. Then I want to find the function. Is 3. I is 0. And then points will be changed to control points here. Okay, here we are. Okay, we have the cast, and also we have, okay, actually here we can change to new, right? Okay. Okay, next we want to check whether the cast here and the new Bezier curve are the same. Are they the same? เหมือนกันไหมคะ Are they the same? We cannot check, right? So I will use this one. Simplify. It's a magic function, simplify, right? Okay, and then or can use expand. Use simplify. And we use simplify here. Are they now the same? Yes. It's supposed to be yes. If you want to make sure, if you cannot read it, you can just simply, in Mathematica, it's very elegant. You can use equal sign in order to check for the equality of two statements, two expression. And then if they are equal, so it will return true. True. Okay, we have already had the Bezier curve in the terms of the Burnside polynomial. and we also have the Casteljau algorithm. We put the input that is that is the same. That is a control point set, right? So here we come out with the same polynomial. So we can guarantee that, okay, the Casteljau are the same. The Casteljau algorithm can compute the same polynomial, the same value as the Bernstein polynomial. So now you have two nice algorithms. The first one is you are trying to use the Bernstein polynomial in order to compute the Bezier curve of any degree n. You can write down the Bezier curve of degree 10, degree 20. Okay, you can write it. You can also draw the Bezier curve in three-dimensional, in two-dimensional. It doesn't matter. Also, you can also use the Casteljau in order to do the same thing, right? You can just simply change the control points here and then you can get the result. Okay, you can also use the parametric plot if you want to draw in 2D, or if you want, you can use parametric plot 3D in order to draw the curve in three-dimensional space, right? It's up to you. But I've passed this phase, right? I want to remark you here before we will stop today's class. That is, if we want to represent the cubic, the Bezier curve of degree n in matrix representation, I always tell you that this is the form that is very famous and very useful in any kinds of programming languages. If you want to draw the curve, right? If you use the Bernstein polynomial form, right? You may have to use MATLAB or Mathematica because they are good in symbolic computation. But if you have C programming or Java programming, maybe you have to use the Casteljau algorithm. But anyway, the Casteljau algorithm is a recursive algorithm. So if you have bigger n, so because it is n squared, right? The complexity is n squared. So if you maybe, let's say, if you have n for 30, 40, it does matter. Okay, so in order to guarantee that your program will not be halt or stopped or terminate, right? So you may have to represent it in terms of the matrix representation. This is what I show you here. It is a matrix representation for Bezier curve of degree 3. What happens if I want to have the matrix representation of degree 4 or degree 5? How can I get it? Okay, I believe this to all of you to be homework for all of you to find the general form of matrix representation of Bezier curve of any degree. Okay, you can find it. And then we will talk about this later next week. Thank you very much for joining, for attention this course.